Okay, so these are the notes for the graphing your motion. So you're going to be putting two things in your interactive notebook. You've got the graphing your motion notes, which is this page that you see right here. And then while you're taking the notes, we're also going to be doing some practice together. And it's this page that looks like this. It's got the practice questions. So we're going to flip between doing practice on the practice reading a graph and filling in the notes on the graphing your motion notes. So you guys are going to be entering into a new unit, on force and motion. So let's talk a little bit about what motion is. So when an object changes position over time relative to a reference point, we say that the object is in motion. So that means that a moving object is an object that has changed its position over time relative to a reference point. So if I'm standing in the hallway and I watch somebody walking past me, I can be the reference point, and that person walking past me is in motion. Or I can watch somebody walking past a locker, so I can see them moving with a fixed reference point. You have to watch the object in motion compared to a reference point. Otherwise, it seems like the object stays in place. Think about watching a car drive past a tree. If I was watching a car driving next to me and I'm going 70 miles per hour and that car is going 70 miles per hour and we're both looking at each other, it might appear like we're not moving at all. But if I watch the motion of that car whizzing past a tree at 70 miles per hour, then I can tell it has motion. So we tend to represent the motion of objects on graphs. And there's two types of graphs we're going to look at today, which is a distance time graph and also a velocity time graph. So let's look at the distance time graph. So the distance time graph can tell us a lot of different things. Notice first of all that my time here is on the x-axis, it's my independent variable, and then the distance is on the y-graph, so that means that's what we're measuring, or that's what we're watching change. Okay, so there's a couple things we can see about this. First of all, leading up to point A, we can see that this object is moving away from the reference point. So in this case, it's John's house. John is walking away from his house. Okay, notice that the slope has changed slightly. So from here, from this point to A, I would say that they are moving a little bit more slowly. John's moving slowly. When the slope increases, like here, we would say that there's faster motion. That's your next blank. You're filling these blanks in on your note sheet here. There's 4 little text boxes for you to fill in on your note sheet. Now, all of a sudden, between B and C, the line stays flat. So look, as time passes, his distance doesn't change. So he's just standing still. This is like you walked from your front door to the bus stop, right? And all of a sudden you realize that the bus is there, so you move a little bit quicker. And now you're standing in line while people are getting in the bus before you, so you're not moving. So this flat line on a distance time graph indicates that there's no motion, you're standing still. Or this could be a car driving, maybe they speed up a little bit and all of a sudden there's a stop sign or a stoplight, so now they're standing still. Now, what about when we have this negative slope? The slope is going down. We call that that the object is now moving again, but look what's happening to the distance. The distance is decreasing, so now it's moving towards the reference point. So maybe this is John realized he forgot something, and now he's running back towards his house. So his distance is going back towards the reference point. So those are 4 things that we can tell from a distance time graph. If we see that the positive slope from A to B here, that's a positive slope, we're moving away from the reference point. Distance is increasing as time is increasing. If we see a flat line, then we know that there's no motion. If we see a negative slope, then we know we're moving towards the reference point. So it's like we're going backwards. We're going back to where we started from. Let's practice. Now switch over to your practice sheet. So you're going back to your practice sheet now. And you should see these same 4 graphs here with these 4 questions. Question number 1 says, which graph above shows an object that is still? So take a minute to think about these 4 questions, and you're going to write the letter of which graph. A, B, C, or D indicates that an object is sitting still. Question 2 asks, which graph above shows an object speeding up? Question 3 says, which graph above shows a constant speed? And question 4 says, which graph above shows an object slowing down? So take a minute right now to answer each of these questions, 1, 2, 3, and 4, by selecting graph A, B, C, or D. You can use each one once and only once. You'll use them all. We'll come back and check your answers in a few minutes. So now let's talk about the second type of graph. Now you're going back to your graph notes page. The second type of graph is called a velocity and time graph. Another way to think of velocity, if you're not recognizing that word, is it's very similar to speed. So it's like looking at the speed that an object is moving over time. So this could be like 10 meters per second, 20 meters per second, 30 meters per second. Another unit might have been miles per hour or kilometers per hour. So this is how fast it's moving, and this is how long it's taking it. So here we see that there's 3 different key features that we can read on a velocity time graph. Letter A is representing what we call positive acceleration. This object is starting to move faster over time. It starts out here at 0, now it's going 10 meters per second, now it's going 20 meters per second. So after 10 seconds, it's sped up. This is like a car was waiting at a stoplight, the light turned green, they're accelerating, they're going faster. It's positive because that's a positive number. If we were to calculate that acceleration, we would take 20 meters per second divided by the change in time, which would be the 10 meters per second, comparing it to where it started, 0 meters per second. So we would actually say that this car is accelerating at a rate of 2 meters per second. We'll get to more about that later. Now, letter B, notice the line is flat. Now, on a distance time graph, that would mean that it's standing still, but look at the speed. That means that this object is still traveling at 20 meters per second. So it's still moving. It's not standing still. Its velocity is 20 meters per second. That's moving pretty quickly, but it's not changing. It's not increasing or decreasing. So we call that no acceleration. No acceleration. Another way to call that would be 0 acceleration. That means it's not speeding up, it's not slowing down, so there's no change in its speed or velocity. Then it's called 0 or no acceleration. And then we notice here, as we have the negative slope as it's moving down, that it is going to be losing speed. It started at 20 meters per second, but look at this. Eventually it's going down to 0 meters per second. So this object is slowing down to a stop, kind of like a car sees that there's a red light ahead, so it starts lowering its speed, and eventually it stops. And so we would call that negative acceleration because it's losing speed over time. We could calculate this acceleration, it would be a negative number. If I'm doing the math right in my head, I think it would be negative 0.5 meters per second. So that means every second that goes by, this object is traveling a half of a meter per second slower. So again, positive slope, positive acceleration. No slope, 0 slope, no acceleration or 0 acceleration. And then negative slope, negative acceleration. So this means speeding up, constant speed, slowing down. Time to go back to your practice sheet now, and the more practice. 3 questions here. Now look at this as a velocity or a speed versus time graph. And so we're wanting to look at R. We see that there's an increase in speed over time. S, constant. T, negative, so it's slowing down. U, it's constant again, but it looks like it's constant pretty much at 0, so it's standing still. This is like the cars at the stoplight. And now it's speeding up, and it's constant again. So imagine this. The car was at a stoplight, it's got a green light, it goes. It's speeding up really quickly, they're racing along. Now it's cruising at a normal speed, it's staying at the same speed. It sees the stop sign or stoplight, so it slows down. Now it's waiting. Maybe this is a stop sign because this is only 4 seconds. So it's waiting, it's not moving at all for 4 seconds. Now it's speeding back up and again moving at a constant speed. So answer these 3 questions. Which letter would indicate that a car started speeding up at a constant rate? R, S, or T? Number 2, which letter would indicate that a car is moving at a constant speed and not accelerating? And number 3, which letter would indicate that a car was slowing down to a stop? So let's quickly actually check your answers. I want to make sure that you have the right answers in on your practice. So if you're looking at your practice reading a graph, let's check your work. So number 1 up here, which graph above shows an object that is still? So it's still, it's not moving. The correct answer would be B. Notice that this is a distance time graph, and so the distance has not changed. So obviously this object is just sitting still as time passes. Number 2, which graph above shows an object that is speeding up? Well, technically, there are several graphs that you could answer this. A, C, those are both speeding up, okay? We would probably go with C, though, because this one is speeding up and getting faster and faster and faster. So here I'm going a certain speed, but now I'm getting faster and faster with time. So I'm actually increasing my acceleration. Number 3, which graph above shows a constant speed? That would be letter A would be the best, because notice there's no curve to the line. Every second that passes, my distance is changing, so it's equal. This would be a car that's just every second that passes, it changes the distance in equal intervals. So lastly, number 4, which graph shows an object that is slowing down? That would be letter D, because notice that it seemed to be going faster before, but now the line is starting to flatten. And the more the line flattens, it shows that it's slowing down. It's moving less distance as time passes. And now let's check on our velocity time graph. Number 1, which letter would indicate that a car started speeding up at a constant rate? R, S, or T? So I have R, S, and T to choose from here. Speeding up, that would be positive acceleration. That's here, letter R. This car is speeding up. It's going 0 meters per second to 2 to 4 to 6, all the way up to 20 meters per second. Number 2, which letter would indicate that a car is moving at a constant speed and it's not accelerating? Of course, that would be S. So it's constant speed. It's speeding. Look, it's going 20 meters per second, so it's moving, but it continues to remain at 20, so it's not accelerating. And then lastly, which letter would indicate that a car was slowing down? T.